Okay, now in part 2 of parametric equations, I have put some lines here just for easy explanations here. So the graph C shown below is defined by parametric equations: x3 sine 3 theta, y equals 6 cos 2 theta for that pi thing. So now here question 1 says, so this is the curve that is being defined by these parametric equations here. So now they are saying write down the value of dy d theta at the point 6, 0,6. Now 0,6 is the point here, and you can see at that point, if you draw a line, this is a horizontal line. Now we know that horizontal and vertical lines do have gradients equals to 0. So in as much as this may seem to be a tricky question, it's actually very easy, because at 0,0, that's the turning point of this curve. So at that point, dy dx, dy d theta is simply equals to 0. And then write down the value of dx d theta at -3. This line here, at this point here, that is where there is -3,3, and then this is where there is 3,3. Again, this is a vertical line, perpendicular vertical lines. All these points, dx d theta is equal to 0. So these are very basic questions on your understanding of gradients. So that's just what we needed to realize for this number 3. The most interesting part of question number 3 is actually then we do B, find dy dx in terms of theta. So now here, this is where we'll do now a little bit of our work. So I'm going to write these equations down here. We've been given that x is equal to 3 sin 3 theta, sin 3 theta. So I'll just write that properly. So we've been given x is equal to 3 sin 3 theta, and y is given as equal to 6 cos 2 theta. 6 cos 2 theta. So now they are saying we find the dy dx for these equations here. So what we need to do now here is to find dx d theta first, and we are just using normal differentiation of the sign here. So dx d theta is simply equal to, because when we differentiate the sine function, we get cos, and we've got a 3 theta here, so we're going to get 3, which is just this, times 3 cos 3 theta, which gives us 9 cos 3 theta. For the derivative of this, you can confirm that. I saw in the previous assignment you managed to get such equations, the derivatives of such equations. Then dy d theta for this one here is simply going to be equal to, again, this is 2 theta, sorry, here. Again, we know that the derivative of cos is actually negative sin. So this means that we are going to find, so this was 2 theta. We know this is going to be 6 times the derivative of cos, negative sin. But again, we need to differentiate 2 theta here. So this is going to be negative 2 sin 2 theta. So if we do our work there, we find that now we've got dy d theta as negative 12 sin 2 theta, like that. So that's our dy d theta. Now the question says find an expression for dy dx. We know that dy dx is simply equal to dy d theta times d theta dx. So if we do our math here, our dy d theta is negative 12 sin 2 theta. So we put 2 theta there, and then over 1 times d theta dx is just a reciprocal of this, which is 1 over 9 cos 3 theta. Okay. So if we do our math here, this gives us theta being negative 12 sin 2 theta over 9 cos 3 theta. So we can simplify these now. Let me just make space here. We can simplify this to give us dy dx being equal to negative 4 sin 2 theta over cos 3 theta. So this is our dy d theta. So this is going to be our dy d theta. So this is the answer that they wanted us to do for part B. A very nice question. And then I think where we need to do a little bit of some thinking is on the last part of C. C says find the value of x and y and dy dx at the point where theta is equal to that. Okay, so they want us to find the value of x at the point where theta is equal to that for part 1, and then hence show that. So this is again a very, very nice question. So what I'm going to do first, I'm going to write what x is equal to here. X is given as, just copy up here, 3 sine 3 theta, okay, and then y is given as 6 cos 2 theta, okay. So now those are the equations that we have. So they want us to find the values of x and y and dy d theta. Remember that we've already found dy d theta here, dy dx in terms of theta here, okay. So what they want us to find are the values of x and y. So to find the value of x and y given theta, all we are going to do is x is equal to 3 times sin 3, then this is multiplying the value of theta that we are given, which is pi over 12. So if we do this, x is actually equal to that is that, so this gives us 3 times sin pi over 4, and then sin pi over 4, if you use your calculator here, these are just spatial angles. If I check nicely, this should give me root 2 over 2. So this gives me 3 times root 2 over 2, yes. Which implies that x is equal to 3 root 2 over 2. Okay, so we keep that. Then we are going to do the same. We are also going to do the same here for finding the value of y. So I'm going to create space here. To find the value of y, now we are going to do again the same thing. We know that y is 6 cos 2 theta, but where there is theta, I'm going to put pi over 12. And then this gives me y equals 6 times cos 2 goes into 12, 6, pi over 6. And then if you use your calculator here, you must get 6 times pi over 6, which is root 3 over 2, root 3 over 2, and it implies that y is equal to 2 can go into the 3 root 3. So we found the value of x here, and we found the value of y. So what we are simply doing here is replacing theta in the x and y parametric equations. So if we do that now, so that's that. Then to find dy dx, remember, we already have our dy dx up here in terms of theta, which was given. So our dy dx here, which we found, was negative 4 sin 2 theta over cos 3 theta. Okay. Now here what we're just doing is basic substitution. So let's go back. What did we do here? Oh yeah, I just want to bring you back a little bit here. I think I missed, there's a 3 that goes into 12. So this was over 3 here. Sorry, I think you must have picked that because we had negative 12 over 9. So 3 goes into negative 12, negative 4. and then 3 goes into 9, 3. So that was a mistake that I made there. So this should have been 3, and I hope that's not a very huge mistake. Now, what we are doing here, we are replacing theta into there. And if we do our dy dx, we then realize that we've got negative 4 times sin 2 dot theta, which is pi over 12 over 3 cos 3 times pi over 12. Now, this is just a clear use of a calculator here, which we are very much allowed to do. If you do your work nicely, to give you, punch everything on your calculator, 2 root 2 over 3. So this is the answer for dy dx. So for the first part here, all we are doing is actually replacing the value of theta into our x and y parametric equations and the dy dx. Then for maybe part 2 of C, hence show the equation of the tangent to C at the point theta. So this point theta is the theta that we just replaced in our dy dx, and we are saying the gradient is actually negative 2 root 2 over 3. And we know that the equation y, straight line equation, has this form here, m, where m is the gradient, and we've got x minus x1. Okay, so we've got the gradient, and we're just going to replace there because this is the equation of the tangent to the curve. So our m is that, so our y1 is actually this one that we found here, and our x1 is 3 root 2 over 2. So all we are doing now here is replace these values here. So I'm just going to do that quickly here. So I'm going to write this as 3 root 3. So we've got 3 root 3 here equals our gradient negative 2 root 2 over 3 multiplying x minus our x1 is 3 root 2 over 2. So all we are doing is expand this, collect everything on one side. It must come and give us this equation here. So in this case now, what we're going to have, what I normally like doing is I'll expand first the brackets. Okay, so expanding that means this is going to be negative 2 root 2 as it is over 3, and we put our x here. Now when I multiply this guy with that, okay, what I'm going to get is plus 2 root 2 dot 3 root 2, okay, over 3, okay, because I'm multiplying the top and the top. So the top and the bottom, sorry. So this is going to give me now 9, okay. So I'm going to get 6 here, because 3 times 2 is actually 6, and negative 2 root 2 times negative that will just give me plus the negative. So that's what we have here. Now here what we are doing now in this case is y minus 3 root 3 would then be equal to negative 2 root 2 over 3x. But then 3 times 3 gives me 6. So I've got plus 6. Then square root of 2 times square root of 2 is simply 2. Okay, over 6 as well. You can punch this on your calculator to see how it simplifies. So I already know that 6 and 6 would divide to leave me with 2 here. I've got a y minus 3 root 3 equals negative 2 root 2 over 3x plus 2. Now let's go back to what we are asked to show. They want it to be without any denominators here. So what I'm going to do now here, there is a 3 at the bottom. I will multiply this whole equation by 3 so that this 3 can cancel. So 3 times y gives me 3y. 3 times negative 3 gives me negative 9 root 3 equals, if I multiply this guy and that guy, that gets to cancel to give me just negative 2 root 2x plus 6. So now my job is to bring or transpose all of these onto one side. So if we do that, we must actually get our answer that they want us to find. So I'm going to do it here. And so what we're going to have is, if this moves, it's going to be 2 because it becomes positive 2, and then there's x here, then there's a plus 3y, then minus 9 root 3 minus 6 equals to 0. Now if you look at this, I can write this as 2 root 2x plus 3y. I pull out the minus and put these guys into brackets as the question indicates. This becomes plus and then equals to 0. You can see that this now would mean, before I even conclude here, I can simply just write this as 2 root 2x plus 3y minus, then I put 9 root 3 plus 6 equals to 0. So this is the same, so we can then just say hence shown. That means we will have shown, because that comes out as what we were asked to do. So what I just want to go back on is here I missed negative 12 over 9 is negative 4 over 3, but at first I said negative 4. I forgot about that 3, but anyway, nice, I picked that. So this was a very good question. You can go back and rewatch this same thing. It's usually about substitution. And let's look at question number 4, which is the last question I want us to look at here. So I was trying to, okay, question number 4. So now for question number 4, which I think is the last question that I'm going to do on this worksheet of parametric equations. The curve C has parametric equations: x equals 2 t squared, y equals 2 sine t. Show that in terms of t, dy dx is equal to cos t over t. So here again, we already know we need to differentiate x in terms of t and y in terms of t, then do our algebraic manipulations to get dy dx. So to quickly run through this, we know that dx dt is just going to be equal to 2t because we are just differentiating t squared. And then we know that the derivative of sine is cos, so our dy dt in this case is going to be equal to okay, sorry, just our dy dt is equal to 2 cos t. Okay, now we must know that to get dy dx, okay, we need to have dy dt times dt dx. Now you realize that dt dx here, this component here, is the reciprocal of dx dt, which implies that dt dx is simply going to be 1 over 2t. Okay, since dx dt is 2t, so the reciprocal of it would be that. So this is what we're going to multiply by dy dt, because then that means we are going to cancel out that to obtain our dy dx. So our dy dx then in this case is simply going to be equal to 2 cos t over 2t. Okay, and you can see here that there is a common 2 that can divide to give us cos t over t, and then this gives us our dy dx, and hence shown, because this is what they asked us to show. Okay, now there is the next question here, which is a very nice question. Show that the distance between the maximum and the minimum point on C is that. Okay, so now you look at this curve C that is given. They are saying show that the maximum and minimum point. Now whenever they talk about the maximum and minimum of a point, we know we are talking about turning points. So right away here, what needs to come to our mind is that we need to find the turning point, and we already have our dy dx. So I'm just going to write our dy dx here. So our dy dx is cos t over t, and to find the turning point, this must be equated to 0. So what I'm going to do here is cut this into segments so that I make the most out of this space that is here. I'll just cut it into 3 different parts. Okay, now if we solve this equals to 0, we are going to just cross multiply there to mean cos t is equal to 0, since t times that is that. Now there are 2 values at which cos gives you 0. We know that from P1. If we solve into all the 4 quadrants, all students take coffee, our famous statement here. We know that t equals to 0 means, cos t equals to 0 means, first we are going to get one thing about our equations here. So what we are going to get is cos t is equal to 0 at 90 and 270, 3 pi over 2, since we are using radians. So these are the 2 values at the turning point for t. Okay, now for each one of these, we must find their x and their y. Okay, so we've got these guys here, and remember we've been told that x is equal to t squared and y is equal to 2 sine t. Okay, so these are the t values at the turning points, and what we need to do is for each one of them we need to find the x and y. So we've got x being equal to half squared, since it's t squared, which gives us x being equal to pi squared over 4. And then for this other one, for y, when x is that, I'm going to have y equals 2 sin pi over 2. Okay, if I do that, I know that my y is going to be equal to, what would my y give me here? My y is going to give me 2, because sine of pi is 1. So 1 times 2 gives me 2. So it means this coordinate point actually is pi squared over 4, comma 2. This is one coordinate point when t is equal to half pi. So we need to do the same for this other value of t here. So I'm going to say x is equal to 2 multiplying, not 2, sorry. So x is equal to 3 pi over 2 squared, which then means x is equal to 9 pi squared over 4. And then for this same value of x, we need to go back to the original, and we've got that y is equal to 2 sine t. We need to find its corresponding y coordinate. So what we're going to do now is y equals 2 sin, then 3 pi over 2. And if we do this, we know that sine at 270, if you're not sure, just punch this on your calculator, is -1. So it means this point is -2. Okay, y is -2. It means the next point at the turning point, the next turning point has 9 pi squared over 4, comma -2. Okay, now they are talking about, show that the distance between the maximum and the minimum points on C is that. What we have is x being equal to t squared and y equals being to 2 sine t. Now this is a very nice question, and what I'm going to do then is to show you one thing that goes. You know, if you were to draw a rough sine function, okay, let me just try to draw it here. You know that sine is a graph that moves like that, and at 90, which is half pi, this is equal to 1, and this is pi over 2 comma 1, and then this is 270 from what we know about sketching graphs already. So this is 3 pi over 2 comma -1. This is the original y equals sine sine theta of the graph. Now, this question says, show that the distance between the maximum and minimum point. Okay, so now in this case, what I want you to visualize, although this line is a straight line because they're saying, so now what they want you to know is the distance from this point to that point, that straight line that I've drawn there. Now, a straight line equation is already given as x2 minus x1, if you remember, squared, plus y2 minus y1 squared, and everything in the square root when we did coordinate geometry. So for this point, since we've got one turning point here and another turning point there, and they want the distance between the maximum and minimum, just as I've drawn a rough sketch for the normal sine function here, we just use this formula to then find what this distance is equal to. And then they want us to say it comes out as that. They've already given us that. So what our duty would be here, you can name any one of these x1, y1, y2, x2. So what we are just going to do now here is say 9 pi squared as our x over 4 minus pi squared over 4. This is squared. Okay, of course, everything is going to be under the square root. Then we add this to negative 2 minus 2 squared. So if we do our algebra here, you can see the denominator is 4. This is 8 pi. So we've got 8 pi squared over 4. Everything squared here plus negative 4 squared. And everything here is under a square root. Now, if we do our work property here, you would find that this is 2 pi squared, okay, plus 16, and then everything in the square root. Now here, 2 pi squared means 4 pi power 4 plus 16, and then we are trying to find the square root of this. I can factorize the 4 inside to have pi 4 plus 4, and then there's a square root here. Since I don't know the square root of this and I know what the square root of 4 is, which is 2, I can say this is 2, then root of pi over 4 plus 4, hence shown, because this is what they said we should show. So we will have shown that we are good and we get our full marks. I don't know how many marks this question had. So thank you very much, and please, you can try the other questions, but these are the 4 questions I picked which I thought would actually help us revise almost everything we needed on parametric equations. I'll be doing another one on implicit differentiation, which is again another good type of differentiation, and you already answered it in the previous assignment. So these videos are just for review purposes. So thank you very much. Please send me any questions that you may meet in my assignments or anything that you may want us to discuss. I'm actually very much available.